In this video, I'm going to solve a problem related to a roller coaster. There used to be a roller coaster at Kings Island called the Screamin' Demon, where you start at the top, go down through a loop, back up here, and stop, and then you go backwards, do the exact same thing. That was the whole roller coaster. So the longest part about the whole thing was climbing the stairs to get to the starting point. So in this question, we'll be looking at the kinetic energy of the roller coaster and how high this has to be so that it can stay on the track at the top. It says here, identify concepts, write all these things, write the equation. It doesn't say to solve it. I'm actually going to go through and solve it as well. Okay, I always like to use energy to solve problems if I can. This one, I think I can. So that's what we're going to try here. So the car starts up here, not moving. So velocity is equal to 0 because it says it starts released from rest at some height. The initial height, 54 meters, comes down, loops around, and then the question is, what is K at the top here? Find the kinetic energy at that point. So we'll use conservation of energy. So initial energy equals final energy since there is no external work being applied. So initial energy, this is K initial plus UG initial plus UE initial plus E thermal initial equals final. K final plus UG final plus UE final plus E thermal final. Whew. No springs. 0, 0. No friction. So the initial and final will cancel out for thermal energy, so we can make those both 0 as well. Kinetic energy initial speed is 0. So that means there is no energy of motion. So that's 0. The only thing left is gravitational initial. So UG initial, that's mg y naught, equals K final. So final position is at the top. We're not interested in what happens later. That was what we'll use as our final position. So K final is K at the top. That's what we're looking for. Plus UG final. So that's M times G times this Y initial. I should change that to make it consistent. If I make Y equals 0 here, that makes it easier because my Y initial then would be H. MGH. MG, what's my height at this point? If I have R, there's an R here and an R here, so this height is 2R. mg times 2R. So kinetic energy at the top is mgh minus 2mgr. So that is, mass is 50 kg, 9.8 meters per second squared, times h was 54 meters, minus 2, 50 kg, 9.8 meters per second squared, r, 18. And that is 8,820 joules. So that's the first question, K at the top. The second question, what would the minimum height have to be so that it stays on the track? This question is more complicated. In order for it to stay on the track, now we should switch to forces. So if I draw the free body diagram of this cart sitting there, it is sitting on the underside of the track. So the normal force from the track is pushing down on it. It's also got gravity. pulling down on it. Normal force and gravitational force are the only two forces that are affecting it at this point. Now, for it to just barely stay on the track, that would mean normal force is near zero. So it's just barely touching. It's not really the force, the track isn't really pushing on them. So we're looking for the point where n equals zero. So gravitational force is the only force that's affecting it. It's moving in a circular pattern. So if it's moving in a circle, that means it's got centripetal acceleration caused by centripetal force. The only force that can be is mg. So mg has to be the centripetal force. And centripetal force is mv squared over r. We can use that to find out what the v has to be. Actually, we can use it to find what mv squared has to be. So mv squared has to be equal to r mg. I left it mv squared altogether because that means 1/2 mv squared has to be 1/2 r mg, which is what k at the top will have to be. So if k at the top is 1/2 r mg, we can use this same thing. So this was for the first problem. For the second problem, k at the top has to be at least 1/2 r mg, and that has to be equal to mgh minus 2 mgr. This time mg goes away in every one of them. mg, mg, mg. So 1/2 r is, h is what we're looking for this time, the minimum h. So that's minimum h. So we're going to add 2r to both sides. So 1/2 r plus 2r, that's 2.5 r, which is h min. So h min, if r is 18, 2.5 times 18 is 36 plus 950, 45. 45 meters.